Good morning everyone. Today I'm going to show you the video solutions for self-study exercises number 20 on aldehydes and ketones. Let's start from problem 1. You should give names for the following compounds and identify whether this is a ketone or an aldehyde. So the first one, we clearly see that this is a ketone, okay? And when we name ketones, we always try to give the carbonyl carbon the lowest numbers possible. So if we start numbering from the left, 1, 2, 3, 4, we have butan 2-one, specifying the location of the carbonyl carbon, and also we have one substitution on the 1, 2, 3 on the third carbon, which is methyl. So we have 3-methyl butan 2-one to be precise. Okay. The next compound is a cyclic compound. It is also ketone, right? Because we don't have any hydrogen attached to carbonyl to oxygen in carbonyl group. Okay. And the carbonyl carbon, which is this one, always gives number 1 in the cyclic compounds. So if this is number 1, then 2, 3. We have one substitution here on the third carbon. It's going to be 3-bromo-cyclohexanone. Okay, 3-bromo-cyclohexanone. There's no need to specify the location of carbonyl carbon because by convention it's always number 1. Okay. The next compound is again another ketone. Okay, we have a carbonyl group here. So how do we name this one? 1, 2, 3, 4. We have 2 substitutions, one hydroxy group and one methyl group. So that's going to be again butan 2-one, right? But I have 2 substitutions. One group is hydroxy, okay, which is on the 4th carbon, and one is methyl group, which is on the 3rd carbon. So I will use an alphabetic order, okay. So I will list first hydroxy group. That's going to be 4-hydroxy, 3-methyl, butan 2-one, okay. And the final compound is an aldehyde, okay, because I can clearly see there's a hydrogen attached to carbonyl carbon, okay, and in aldehydes we always number from this carbon, okay. So this is number 1, 2, 3, 4, 5. 5 in total. There's one substitution on the 3rd carbon. That's why we would achieve 3-methyl pentanal. Okay, and that's going to be the last compound. Okay, in problem 1b, all right, you have to decide, okay, in I, which would produce a red precipitate of copper 1 oxide when boiled with Fechlin solution. Okay, so if I consider all the compounds in problem 1a, I know from the lecture material, I should know that aldehydes are reacting positively with different oxidizing agents, such as, and one of them is Fechlin solution, right? So the only compound that would actually produce a red precipitate of copper 1 oxide would be pentanal, okay, 3-methyl pentanal. The compound that we have here will be reacting positively with Fechlin solutions, which is a copper 2 plus oxide, which is a copper 2 plus complex solution, okay, and aldehydes are oxidized to either, so in basic solutions, they would be oxidized first to the salt of the carboxylic acid, okay, so in this case we would have O-, and then they are further protonated to carboxylic acids. So if the starting material is 3-methyl pentanal, the final products is 3-methyl pentanoic acid plus copper oxide, okay. And the solution colors, original color was blue, okay, and it changes to red, okay, because of the presence this precipitate. Okay, the next question. The next question is which one from the compounds above would react positively with Tollens reagent? Well, Toland's reagent is another oxidizing agent, right? And of course, we already said that the aldehyde should react positively with it. And what are the two major products? Okay, what are the two products that will be formed in each reaction, in each positive reaction? In other words, in each reaction of aldehyde with Toland's reagent, what are the products? So, considering again only those compounds that we were given, I can conclude that 3-methylpentanal would be the one that reacts positively with Toland's reagent, okay? And due to specificity of this reagent, we would get again we would get a salt of carboxylic acid, which is then protonated to an acid, okay? And the second product would be silver, okay? So the color change for this reaction would be from colorless to silver mirror, or gray, or dark gray, or even black precipitate, okay? Will be formed during this reaction, okay? Right, the next question, which one would be reduced to a secondary alcohol by sodium borotetrahydrate? Well, we know that from the lecture materials again that the secondary alcohol secondary alcohols are oxidized, right, to ketones, and then ketones are reduced back to secondary alcohols, okay? So all the ketones in the above problem, okay, will be reacting with this reducing agent, forming secondary alcohol. I only showed you one reaction for demonstration purposes. So if we take the first ketone, which was 3-methylbutanone, okay, which is this compound, reacting with reducing agent, okay, schematically is written as H, and please note that there should be two hydrogens, okay? So we would form a secondary alcohol, and secondary alcohol, which is 3-methylbutan-2-ol, okay? And please note that this carbon is now what? Has one hydrogen attached to it, and to oxygen we have another hydrogen attached to it. Okay, the final one, which one of these compounds would be reduced to a primary alcohol? We know that from the previous lectures that primary alcohols are oxidized to aldehydes, all right? And then it means that the aldehydes would be reduced to primary alcohols. So the only aldehyde we had was 3-methylpentanal, and it's going to be reduced back to primary alcohol, 3-methylpentanol, okay? Pentan-1-ol actually, indicating that the hydroxyl group would be on the first carbon, okay? So we get the primary alcohol. All right, thank you for watching. I'm gonna do the solution for problem 2 and 3 in two separate videos.